A transistor is one of the most common components in circuits. Today, let's learn how to identify its pin order using a digital multimeter. Here are two common transistors, one NPN and one N. Before we test them, we need to understand what a PN junction is. It's formed by combining N-type and P-type semiconductors. A PN junction is also what forms a diode. N-type and P-type semiconductors are made by doping pure silicon with small amounts of different impurities. N-type semiconductors have extra electrons, creating free electrons, while P-type ones have holes due to missing electrons. These free electrons easily move from the N region to the P region. So a junction conducts only in one direction. When forward voltage is applied, electrons flow from N to P. When reverse voltage is applied, the junction is cut off. Note that the conventional current direction is opposite to the actual electron movement. Now that we know the principle, let's see how to use a digital multimeter to find a diode's anode and cathode. It's simple. First, set the multimeter to diode mode, then connect the probes to both ends of the diode. If the meter shows over range, swap the probes. Now it shows a forward voltage of 0.545 volt. That means the red probe is on the anode and the black probe on the cathode. Remember, red corresponds to the P region, black to the N region. Inside a transistor, there are two PN structures, and its three pins are the collector, base, and emitter. Now let's see how to identify these pins using a digital multimeter. Here is a transistor labeled S8050. First, touch any two pins with the probes. The meter shows over range, so we swap the probes. Now the reading is 0.7158 volt. That means the middle pin is the P region and the right pin is the N region. We record this voltage and move one probe to the remaining pin. Now the meter shows 0.716 volt. This means the left pin is also the N region. So this transistor is an NPN type and the middle pin is the base. How do we tell the collector from the emitter? Because the carrier concentrations in the two PN junctions differ, their turn-on voltages are slightly different. Just remember, the collector voltage is slightly lower than the emitter voltage. So, by comparing the two readings, we can tell which is the collector and which is the emitter. The first voltage, 0.7158 volt, is lower than the second, 0.716 volt. That means the left pin is the emitter and the right pin is the collector. Thus, S8050 is an NPN transistor with pin order EBC. Now let's identify another transistor, S9012, using the same method. Touch any two pins with the probes. The meter shows over range, so we swap them. Now it reads 0.7243 volt. This means the left pin is P and the middle pin is N. Next, move one probe to the rightmost pin. The meter reads 0.7 to 35 volt. So, the right pin is P, that means S9012 is a N transistor, and the middle pin is the base. Comparing the two readings 0.7 to 43 volt and 0.7 to 35 volt, the first is higher. That means the left pin is the emitter and the right pin is the collector. Finally, we can confirm that S9012 is a N transistor with pin order EBC.